Polymorphism is a term which means many forms. Take note that the word poly means many and morph or morphism means form. So polymorphism means many forms. So this is another OOP concept or OOP mechanism wherein we are able to use a particular class type as the parent class type or interface type, in which it allows for us to be able to use a particular class type as the parent class type. Take for example, object as a class type. We refer to this as the parent class type, and string class type is a child class of object. So object is the parent class, string is the child class, and say str is an instance of class type string. We create this instance via the new keyword. And the question now is string the only class type of str? Or since string is a child class of object, is str considered also as of this class type object? The answer to that is yes. str in fact is treated as an instance of type string and an instance of type object. So given that str is an instance of this class string, which is a child class of the parent class object, instance str has these two class types. So str is considered a string type and also an object type. Since str's direct class type is string, and string is a child class of object, therefore any instance of type string can also be of this type. So str has two class types, string and object. So since str has two class types, then it's like str has many forms. So this is how polymorphism is employed in OOP. This is what we refer as polymorphism, an OOP mechanism that allows any object or any instance to have two or more class types. So whenever a method, for example, accepts a type object parameter, you can pass str to that as value. Since str is considered an object type, there is no data type mismatch in this case, or data type incompatibility. If a method accepts a type string, say this method accepts type string data, you could also pass str as value to x, since str is not just considered an object type but also a string type. To illustrate polymorphism, let's try this revision in our previous example. Say we override the inherited sound method from the animal class. Okay, this is the original sound method from the parent class animal, which mammal, the child class, inherits from the parent class animal. And we override it because we change the implementation of the method. This is exactly the same method that is inherited from the parent class. Take note, they have the same return type, void, and same method name, sound, and same argument pattern. So this is exactly the same inherited sound method from animal. And when we change the implementation, we are employing overriding. So in animal class, sound is makes unique animal sound. In mammal, it is makes unique mammal sound. And say in human, which is a child class of mammal, human inherits sound method from mammal, which is actually originally from animal. And in human, we employ overriding by changing the implementation of the inherited sound method, and we change it to makes unique human sound. Okay, And in test animal, we have these three instances: A for animal, M for mammal, H for human. And say we create a new method, which is a static method, so that we don't need to instantiate the class test animals in order for us to access or call the sound method from the main method. So we make it or declare it as a static method, so we could just call it directly without instantiating this or without via the instance. Take note that the argument of the method sound accepts an animal type argument. X is animal type. So is it possible to pass A as the value of X? Is there no class type mismatch? There is none, because A is type animal and X is type animal. So we can pass A as the value of X. How about for the second call? We pass M. M is type mammal. And could X accept type mammal as value? The answer is yes, because M is considered type mammal and type animal, because mammal is a child class of animal, as illustrated earlier. Okay? So, what are the class types of A? Class type is animal only. Okay? While for M, the class types are, there are two, right? The class types are mammal and animal. So M is considered class type mammal and class type animal based on our discussion of polymorphism. How about H? H is considered to have three class types. Okay, H is considered class type human, class type mammal, and class type animal. So why is it possible for us to pass the value M to X in the method call? Because M is not just type mammal, it is also type animal. So that's why it is accepted here as the value of X. How about H? H is also acceptable because H has three class types. It is considered human type, mammal type, and animal type. So H can be passed as value of X because H is type animal also. When this is called, we pass A, and this will be A.sound, meaning we are calling the sound method of animal. So this is executed, makes unique animal sound. And when this is called or executed, we pass M in here, so this will become M.sound. So it will execute the sound method of mammal, which is makes unique mammal sound. And lastly, when this is called or executed, we pass H as the value of X, and so this is H.sound. It calls or it executes the sound method of human. So the output would be makes unique human sound. Okay, so let's try to run this. Okay, so this is now the output. This is the output when this is called, calling the sound method of animal. And then the second is calling the sound method of mammal. This is M.sound. And then the third is calling the sound method of human. This is H. So this is H.sound. So once again, polymorphism is an OOP concept or mechanism that allows one object or instance to have two or more class types. And normally this is exhibited by inheritance. So the parent class in our previous example is animal, the child class is mammal, and the grandchild class is human. And an instance of this is H. We define H this way. We say human, H, new, human. So H has three types. It is considered type animal, type mammal, and type human. Since it has three class types, it's like it has three forms. Thus, the term polymorphism. Normally, we cannot define the same name method twice, but overriding allows us to define the same name method of parent class in the child class. Like in this case, if this is the parent or superclass and this is the child or subclass, say we have this method, we have this run method in the parent class, and in the child class, we override the inherited run method. So this is inherited by the child or the subclass. This method is exactly the same method coming from the parent class. Why do we say that these two are exactly the same method? Because they have the same return type void, same method name run, and same argument pattern. Recall again the three items that make for a method signature. These are same return type, same method name, and same argument patterns. Okay, that's the first, second, and third. So if these three are the same, then the two methods are the same. Okay, so return type is the same, method name is the same, and the argument pattern is the same. And for argument pattern, there are three items to look into so that we could say that they are the same argument patterns. What are these three? Recall, first is number of arguments, second is data types of arguments, and third, the order of the arguments. Particularly, we look into the order of the arguments data type. So, the parameter or argument name may not be the same. Like in this case, here it is speed and here it is SP. But what is important are these three items. Number of arguments, okay, it's only one argument, one also here. Data types, it is integer, the same. And the order, it's only one, so it's the same. In my previous example, I used this argument pattern. Say we have string s, comma, int x. This is the first argument pattern. Say this is second argument pattern. This is string m and int y. Are these two argument patterns the same? Say this is method 1 and this is method 2. Are these two the same argument patterns? Let's check the number of arguments. There are 2. 1, 2. This is also 1, 2. The data types of the arguments. First parameter, we have string. We have also string here. Integer, yes, we have integer also here. The order, first parameter or argument is string. The first parameter is string type. The second parameter is integer type. The second parameter is integer type. Therefore, they are the same because it's the same for all three considerations. Okay, it doesn't matter the parameter name, like in this case is s and here it is m. It doesn't matter. Okay, and also here it is x, the integer parameter, while in here it is y. Okay, the parameter or argument name does not matter. All that matters is these three items are the same. So if they're the same, then the two argument patterns are the same. When a child class redefines or change the implementation of the inherited method, how do you know that this is the inherited method? Because they have the same return type, method name, and argument pattern. Then we are employing overriding. We have these two keywords which we use when we are employing overriding. First keyword is super. Super is a keyword that explicitly specifies the parent class. So super keyword refers to the parent class. And this is used to call a parent class method or the original method which is defined in the parent class. So this is used to call a parent class method, the original class method from the parent, when overridden method exists in the child class. So say for example, this is the parent class animal and it has it method, and say this is dog Java class, which we call as the child class or the subclass, and we override in here the it method which is inherited from the animal parent class. So maybe the implementation of it here is it's anything, while the implementation of it here for dog is it's dog food. When we are in here, say we have a main method here in the dog class. When we run this one, we can simply call it this way, it, or you could put here the this keyword, because the this keyword refers to the object itself. This statement is found inside this class, the dog class. So the this here refers to dog. So we are running, or we are calling the it method of the dog class. So the output here would be it's dog food. But when we want to run the it method of the parent class, which is this implementation, then we use the keyword super. We say super that it. Now we are referring to the it method of the superclass of dog, which is animal. So the output here would be it's anything. So once again, the super keyword refers to the parent class original method, while the this keyword refers to the method of the object, not the original from the parent class. Let's take a look at this example of overriding. Okay, we have here a Java class car, and car is the parent class or the super class of the Java class racing car. So racing car is the child or the subclass, and car is the parent class. So the parent class car has two methods: void run without arguments and void stop without arguments. And for the child or subclass, which inherits these two methods from the parent class, and at the same time, this child or subclass employs overriding. Okay, the return type is the same, void, the method name is the same, run, and the argument pattern is no argument, it's the same. So this is inherited and overridden by the child class in here. The child class change or redefine the implementation of the method, the inherited method. In the parent class, the implementation of run method is run slow, while in the child class, the implementation is run fast, because this is a racing car. It runs fast. Okay, while for an ordinary car, it simply runs slow. How about the inherited stop method? Is it overridden? Yes, it is also overridden. So we are also employing here overriding. This is the same as the original method. Take note, it has the same return type, void, method name is stop, and the same argument pattern, zero argument. So the child or subclass overrides two of its inherited methods. The run method is overridden, and the stop method is also overridden. The implementation of stop method in the parent class is stop, while the implementation in the child class is first reduce speed, and then it calls the stop method of the superclass. So it executes this, it calls this. Super.stop refers to this. So this is the one being called, not this one. So when we run this, it calls the run method of the parent class. So we have an output, run slow. If this is the output, first line is run slow, the execution of this. And then this.run, the this here refers to the class racing car. So its own run method, which is this one. So it outputs run fast. Next, it calls the run method. There is no keyword super or this, so it simply refers to its own run method. So take note that these two are the same. When you say this.run or simply run, it's the same method you are calling. This one, this method. Okay, that is executed when you call this, and this is exactly the same method also that you call or execute. It outputs again run fast for this one, and then it calls the stop method of the parent or superclass, which is this one. It outputs stop, And then it calls the stop method of this class. So this one is called, you have an output reduce speed. And then after that, it calls the stop method of the superclass, which is this one. So it outputs stop. For this one, that's the output. For this one, this is the output. And lastly, it calls its own stop method again. So the output is reduce speed, and it calls the stop method of the superclass stop. So again, when you say this dot stop, it's the same as simply stop. This is the same as that. This is the same as that.